Let's see how it sounds. Oh yeah, wonderful. Alright, hope everybody's having a good night. We are just about to get started, and if we check, as we always do, the private leaderboards, looks like nobody from work has done the last 2 days. I don't blame them. Day 17 was pretty hard. Day 18 was easier. And yeah, no one's here, so just you and me tonight, guys. Yeah, and if I go over and look, let me mess with my settings real quick, because something seems a little odd about the way this is broadcasting. Oh yeah, much better, much better. Alright, about 1 minute and 3 seconds left. Pretty pleased, actually. Yesterday, 990 is pretty good. 1602 is not great. We should have realized that we needed to offset sooner, but I mean, that's kind of the point here, is to practice and learn. Got our level 19 already ready to go. In fact, let's go here, see how much time we have left. 41 seconds. We can absolutely commit this. Skeleton for day 19. Commit and push. Commit anyways and push. Push. Okay, there we go. Excellent. Let me sound check. Yep, we're good. In fact, our music might even be a little bit quiet, but that's okay. 5 seconds. And let's go. Day 19, not enough minerals. Your scans show that the lava did indeed form obsidian. The wind had changed direction enough to stop sending lava droplets toward you, so you and the elephants exit the cave. As you do, you notice a collection of geodes around the pond. Perhaps you could use the obsidian to form some geode cracking robots and break them open. To collect the obsidian from the bottom of the pond, you'll need waterproof obsidian collecting robots. Fortunately, there's an abundant amount of clay nearby that you can use to make them waterproof. In order to harvest the clay, you'll need special purpose clay collecting robots. To make any type of robot, you need ore, which is plentiful, but in the opposite direction from the clay. Collecting ore requires ore collecting robots with big drills. Fortunately, you have exactly one ore collecting robot in your pack that you can use to kickstart the whole operation. Each robot can collect one of its resource type per minute. It also takes 1 minute for the robot factory, also conveniently from your pack, to construct any type of robot, although it consumes the necessary resources available when construction begins. The robot factory has many blueprints, your puzzle input, you can choose from, but once you've configured it with a blueprint, you can't change it. You'll need to work out which blueprint is best. For example, Blueprint 1, ore robot costs 4 ore, clay robot costs 2 ore, obsidian robot costs 3 ore and 14 clay, each geode robot costs 2 ore and 7 obsidian, 2 ore and 3 ore, 3 ore and 8 clay, 3 ore and 12 obsidian. Blueprints have line wrapped here for legibility. The robot factory's actual assortment of blueprints are provided, 1 blueprint per line. That's gross. The elephants are starting to look hungry, so you shouldn't take too long. You need to figure out which blueprint would maximize the number of opened geodes after 24 minutes by figuring out which robot to build and when to build them. Use blueprint 1 in the example above. The large number of geodes you could open in 24 minutes is 9. One way to achieve that is 1 ore collecting robot collects 1 ore. You now have 1 ore, collects 2 ore, spends 2 ore to start building a clay collecting robot. 1 ore collecting robot collects 1 ore. New clay collecting robot is ready. You now have 1 of them. Ore collecting does this. You now have 2 ore, clay collecting robot. So you have 1 clay, 2 ore to build another clay collecting robot. You now have 1, 2, and now you have 2 clay collecting robots. The ore collecting robot collects 1 ore, 2 clay collecting robots collect 2 clay. You now have 4 clay. 2 ore to make another clay collecting robot. Then you're gonna have 3, 1 and 3, 1 and 3. You spend this to build an obsidian collecting robot. And then starting minute 12, you're now collecting obsidian. And the total amount is 9, so it's just going to collect obsidian 1 per. Oh no, you have another obsidian collecting robot collecting. Oh, and we're doing geodes, right? Blah blah blah. You now have 4 ore, 4 clay collecting robots collect 4 clay. You now have 25 clay. 2 obsidian collecting robots collect 2 obsidian. You now have 7 obsidian. 1 geode cracking robot cracks 1 geode. You now have 2 geodes. You now have 3. Now you have 2 geode cracking robots. Now you have 5. Now you have 7. Now you have 9. However, by using blueprint 2 in the example above, you could do even better. The largest number of geodes in 24 minutes is 12. Determine the quality level of each blueprint by multiplying that blueprint's ID number with the largest number of geodes that could be opened in 24 minutes by that blueprint. In this example, the first blueprint has ID 1, it can open 9 geodes. Quality level is 9. The second one has 24. If you add up the quality levels, you get 33. Determine the quality level of each blueprint using the largest number of geodes it could produce. What do you get if you add up your quality level of all the blueprints in your list? Let's get our puzzle input. Okay, and all of them... Okay, wow, this is kind of gross, but that's fine. Okay, so to start off, we want a notion of a private static class blueprint. And blueprint, and we have what? We have int or robot cost, int clay robot cost, or robot or cost, clay robot or cost, because it's all, yeah. Int obsidian robot or cost, int obsidian, nope, not what I'm looking for, obsidian robot clay cost, int geode robot or cost, int geode robot obsidian cost. Fantastic. Oh, and this needs to be a capital OR. There we go. So now we can just copy all these, and those become our inputs. We just go like this. Fantastic. We're getting there. The music has stopped. The music is always stopping. The music is just never gonna keep playing. We did need int. Dang it. Okay, that's fine. Then we need this dot or robot or cost equals or robot or cost. This dot clay robot clay cost equals blah blah blah. This dot obsidian robot or cost equals obsidian robot or cost. This dot obsidian robot clay cost equals obsidian robot clay cost. This dot geode robot or cost equals geode robot or cost. This dot geode robot obsidian cost equals geode robot obsidian cost. Fantastic. So there's a blueprint, and we also want int blueprint ID. Int blueprint ID. Let's put a space in there. And this dot blueprint ID equals blueprint ID, which we'll use later. So those are the costs. So now, what do we want to do? We want to simulate I want Boolean enough for another or robot, int or, return or greater than or robot or cost. These are going to be useful in writing our conditionals above. Basically want this same thing. Enough for another clay robot or cost. Enough for another obsidian robot into or into clay. Return or greater than obsidian robot or cost, and Sorry, greater than or equal to. Excuse me. 3, okay, yeah. And this should be geode robot. This needs to be greater than or equal to, clay, greater than or equal to, obsidian robot clay cost. Fantastic. And this last one takes in ore and int obsidian. And this should be geode robot ore cost and obsidian greater than geode robot obsidian cost. Okay, cool. So we've got all that. Got the ID. Cool. So now I also want a class that's representative of private, static. Actually, let's come back to that. Let's read in the input real quick. While scanner.has has line, string line equals scanner.next line. Int blueprint ID equals 1. At the end of this, blueprint ID plus plus. List blueprint list equals new array list of blueprints. We can actually, we know that there's 30 blueprints, so we're not that worried about it. Let's give ourselves a little bit of space. String parts equals line dot split space, and this needs to be an array of strings. Blueprint list dot add new blueprint ID integer dot parse int parts. Cool. So this is, how many ints is it? 1, 2, 3, 4, 5, 6. So we're just going to copy this 6 times. Almost. 1, 2, 3, 4, 5, 6. Okay, so. Oh, and we don't need to have a counter here actually. The blueprint ID is also one of these. So this is 1 dot substring 0 1 parts 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30. Yeah, that looks right. Now we're just gonna go here and hit tab. There we go, that looks a lot better. Let's go ahead and just, oh gosh. Just trying to get the formatting right. You know how it is. Okay. Fantastic. So that reads in all the blueprints. And now for each blueprint, we want to, the blueprint itself can find like the maximum number of geos. Int max geodes retrievable. Let's go possible. And then what we want to do is we want to trying to think if this should live on the blueprint or if it should live on like the simulated state class. That's fine. And max turns. So now let's make the static class private. Static class simulation. We need an int or need an int or robots. Need an int clay. Need an int clay robots. Need an int obsidian. Need an int obsidian robots, and we need an int geodes. An int geode robots. It's weird that geodes is plural, but obsidian it's a, you know. Anyways, fine enough. So then simulation doesn't need to take anything in. We're also going to want a simulation copy return. Okay. Simulation new simulation equals new simulation. New simulation dot or equals or 1, 2, 3, 4, 5, 6, 7, 8. Let's go or robots. Clay robots. We're just trying to get everything copied over. We also want like an int, like time, I guess. Time. Each time. This dot time equals time. Actually, we don't even need the time. We're just going to assume that we are always starting at time equals 1 or time equals 0. End of minute 1. So minute 24 gets to run. So we get to start at 0. Start time equals 0. This dot or equals 0. This dot or robots equals 1. Then everything else. This dot play at 0. Equals 0, equals 0, equals 0, equals 0, equals 0. Fantastic. Let's click the music. Now we need to return new simulation. We also need new simulation dot time equals time. And I'm going to make another little helper method called increment, void increment. Or plus equals or robots, clay plus equals clay robots. Obsidian plus equals obsidian robots. Geodes plus equals geode robots. Trying to see if we ever spend. I guess you could spend for multiple robots in a single turn. Oh, that's annoying. Okay. That's fine. My pockets are too full. Let's get that stuff out of here. Okay. Yeah, the more I'm thinking about it, the more I think that this simulation should instead be the thing that's fed in a blueprint. We'll just make it a static method. Increment void purchase or robot. Bless you. Blueprint, or minus equals blueprint dot or robot or cost or robots plus plus. We want the same for all the other robots. Clay robot or cost, clay robots plus plus. It's going to be obsidian robot or cost clay minus equals blueprint dot obsidian robot clay cost obsidian robots plus plus purchase geode robot or cost clay, no, it's obsidian, minus equals blueprint dot geode robot obsidian cost geode robots plus plus. Those are all different. Great. Boolean can purchase or robot blueprint. Now we just want to return blueprint dot enough for another or robot. This dot or. We want to do this same thing. Just clay robot. Enough for another clay robot. Can purchase obsidian robot. Enough for another obsidian robot. This dot clay. Nope, not clay robots. Dot clay. And enough for another geode robot. Enough for another geode robot. This dot or. This dot clay. Okay. Okay, so let's make a little static method now. With static int max geodes from blueprint. Okay, so I want like a queue. What did we use? Did we use this last time? Yeah, array deck is the thing that we want. Queue simulation queue equals new array deck. Queue dot add new simulation. While not queue dot is empty, so just keep running until the queue is empty. What we want to do is simulation current state equals queue dot poll. Then we want int x geodes equals 0. So let's see the termination condition. Current state time is 24. That means it's the end of the 24th minute. If current state dot time is 24, then if max geodes less than current state dot geodes, max geodes equals current state dot geodes. We want to return max geodes. Cool. Yeah. Think about caching to reduce runtime here. Cool. So the else, and we want to just run continue actually, so we don't have to have a gigantic else statement here. So otherwise, if current state dot can purchase or robot blueprint, to deal with multiple purchases in a single unit. Oh, well, we can. Yeah, that's actually use a list. Okay, but we'll deal with that in a second here. Enter nation current but buys or robot equals current state dot copy. Actually, don't we always need to? We have to check if we can buy at the beginning. And then, yeah, so this is fine. Yeah, let's go ahead and use a list right now. List simulation current state mutation list equals new array list current state mutation list dot add current state. So we're going to do some stuff, and then we're going to for simulation in current state mutation list simulation dot I know that one. Okay. I'm getting a little lost in the sauce here. Okay. Okay. Simulation current state do nothing equals current state dot copy. Current state do nothing dot we don't care if it can do anything. We just want it to increment, and then we want q dot add current state do nothing. Cool. Now we just want to do this same set of things. So now we want current but buys or robot. Yeah, get rid of this. Dot increment current state but buys or robot dot purchase or robot blueprint. Which, yeah, it's going to do it after the fact, which is great. Okay, this also doesn't matter. Now we need the same thing but 4 times. Can purchase clay robot, but buys clay robot. Buy clay robot. Fantastic. Can purchase obsidian robot. Buys obsidian robot. Nope. Purchase obsidian robot, and now we need the same thing. Can purchase geode robot. But buys geode robot. Oh, and then we need q dot add current but buys or robot. Q dot add current but buys clay robot. Q dot add this. Q dot add current but buys geode robot. Fantastic. So now we've incremented time, tried to purchase one of each of the robots, gone through. So let's take the simple thing. So max yields from blueprint for blueprint in blueprint list. What int sum, and what did they call this? Sum quality level equals 0. Some quality level plus equals blueprint dot blueprint ID times max yields from blueprint. Some quality level plus some quality level. Fantastic. Let's take our little input here, see whether or not it does what we want. Copy. Don't care about the problem statement right now. This all needs to go on a single line. What's really annoying is that we have to be pretty finicky actually about making sure that this goes through correctly. There we go. Now let's do the same thing here. Okay, that looks better. Let's try running it and see what we get. Java heap space out of memory. Really? That is surprising. Okay, let's go into pretty obviously this. So let's debug. And we'll full screen. Cool. Max yields is nothing. Current state. Q.add. So now our queue has one thing in it. That's fine. Can't do any of these. Is of size 2. Let's just go here. It's size 2, it's of size 3, it's of size 5, 6, 7, 9, 10, and how? Oh, I forgot to increment the time. Increment time plus plus. Okay, this should run real fast now. Stop and rerun. Get on the right side, please. Did I run increment on the things where I bought the stuff? Yes, I did. Still. That is surprising. Okay. So let's debug this. Let's just play a few times. Get back up to when we had, what, 10? Yeah, we have 10 things in the queue. Now time is 3, so that's better. Let's go back to here, click this so we can hear some more music. Here we go. Let's int count equals 0. Here we go. If debug and count plus plus percent 1000 is 0. System.out.println current queue size .out.println. Want to print a few things actually. Current iteration count plus count. Here we go. Plus queue dot size. We're just going to print an empty line at the end. It's time. And we're going to go current state dot time. Fantastic. And then we're going to have a private static final Boolean debug equals true. Cool. Go ahead and run for me. Okay, yeah, so we're getting too big. Okay, so now I'm going 24 ahead. Let's make a cache. Night. Private. We don't even have to. We can just add this on simulation. Simulation increment blah 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 blah. Let's put a thing down at the bottom, right above copy. Wait, what? Oh no, purchase geode. You going to bed? Right. Night. String to cache name. Return new string builder dot append. Gosh, let's copy all of these. Do this real quick. Time dot append. Hopefully this will help some. Cool, so now we need or. Now we need ore robots. Now we need clay. Now we need clay robots. Now we need obsidian. Now we need obsidian robots. Now we need geodes. Now we need geode robots. 2-string. Is that good enough? Seems like it's probably good enough. And we're going to instantiate the cache in here. So the other thing I want is a map string. Oh man. I just don't want to be inserting the same thing over and over again, you know? Oof. Trying to make this thing just run with more RAM. How bad is my RAM usage? Let's go ahead and ignore this for a moment. Oh no, this is correct. Let's go ahead and ignore this for a moment. Edit configurations, main, blah 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 blah. Here, let's look it up together. IntelliJ set Java use more RAM. Decrease the memory heap of the IDE. Help change memory settings. Is that right? Yeah, Windows. Cancel help. Change memory settings, that's what I'm looking for. Change memory settings. How much RAM do I have left? So I can get this, 6 gigs would be a little much, but I can give it 5 gigs. Is that gonna get me where I want? Save and restart. Let's give her a shot. Because I think I got to like 23 or 24. And I guess I'm doing like level order. I guess I'm doing like BFS, and I could be doing DFS. Close. Cool. Try running again. Now that you're allowed to use more RAM. Let's take a look. You're running, you're still thinking. Okay, now you're running. Yeah, here we go. We're doing a little better. Still only at 19. Need to get to 24, which is rough. The current queue size is absolutely monstrous. 1, 2, 3, 4, 5, 70 million. Really? That's all it takes? 70 million of these guys? It's kind of surprising. If we go back to the terminal? No, where's the console? Go back to the run. Here, let's make this 100,000 instead and see if we can get a sense of where we are on the curve. There, get to like 16 instantly, but things get bad from there. Is there some kind of pruning that we can do? Oh, I clicked the wrong button. There we go. Okay, cool. Yeah, so we're still crashing there. I'm gonna take a quick look at the stats and use that to help me determine if like a zillion. No, only 58 people have even done part 1. Okay, that makes me feel better. Okay. Okay, so we can take this and let's make this recursive and then do some caching. So let's pull the music up. Okay, these are still like 7 minutes, that's fine. Let's do the same thing. Goes from blueprint, recursive, blueprint. There we go. Better. So now we can copy most of this, except instead of a queue, I'm going to yeah, no queue to be had. Blueprint. So we want private static int max geodes from this point forward. Blueprint simulation. Yeah, I think we're going to want to start private static final. Oh no, we could just hand the cache around, that's fine. And the thing that has the cache is a map string integer cache. Private static string cache name from. Oh wait, we don't even need to do that then because we're going to be giving this thing the cache. If cache dot contains key simulation dot take me to simulation. What do we call this? One second. I'm going to rename toCache name to get cache name. Great. Back up to where we were. Get cache name. Return cache dot get simulation dot get cache name. Otherwise, we want to do the same logic that we have here. All of this actually. Simulation, all of these are simulation. We can just there we go. Cool. Int max geodes equals 0. Rent int do nothing max geodes equals max geodes from this point forward, blueprint, current state, do nothing, cache, if max geodes less than do nothing max geodes equals do nothing max geodes. Cool. So now we want this same thing. Int by or robot max geodes. Let's do this part at the bottom so that we aren't constantly confusing our variable names. There we go. I actually want to call this max geodes. And then I can actually make this work in these three cases without having to rename a bunch of stuff. There we go. Grandpa buys clay robot. Grandpa buys this. This max geodes. This max geodes. Grandpa buys geode robot. Cool. So then we want cache dot put simulation dot get cache name max geodes return max geodes. Cool. So this just needs to call the same thing with return max geodes from this point forward. Blueprint, new simulation, new hash map of size pretty big. So let's do this. So now let's run this and see if we get there. How did we get so deep? Also, who followed me? That's a terrifying noise. Thanks, Yoshi Boy 18303. Nice to have you. You get to see the infinite loop of yourself because I'm on a laptop and not at home. Okay, scroll up. What's Stack Overflow error? Oh, did we not put a termination condition here? Cool. And then if simulation dot time is 24, return simulation dot geodes. There we go. Much better. Epic follow. I deserve that. Thanks. That's very kind of you. I'm just trying to solve an advent of code problem. It's very hard. And now my computer thinks. Let's check out the RAM. The RAM is going up. Is the cache helping? You're learning Rust over there. Fair enough. I'm writing in Java because that's what I'm comfortable with. At this point, I'm a staff software engineer that runs a team, so like I need something so that I will like stay up to date, you know? Wow, we are using a lot of RAM. I think we gave it 5 gigs. Let's see how many gigs it is using. J, it's using all 5 of those gigs. We should see an exception any second now, unless it's about to get smaller. Well, we haven't crashed yet, but this thing is terribly slow. What are you learning Rust for, by the way? Let's add in some debug statements while we wait. Blah, 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 that's all fine. .out.println computed a blueprint new some quality level plus some quality level. Let's wrap this in an if debug. Yeah, this search space doesn't feel like it should be so huge. Why is this just like using all of my RAM? And all of my CPU. It's using 79% of my CPU for like minutes now. Just so you can be one of the cool kids. A lot of people you've seen using Rust. Might also be good to integrate into new projects. That's fair enough. It sounds like if you're learning Rust just for the heck of it, then you probably already know a bunch of stuff. So that's cool. That's in our data here. Why is this taking forever? Have you already solved the problems today? Like, am I dumb? No hints, just tell me if you've solved it already. Let's go look at the stats, because again, I don't think anybody's solved this yet. Yeah, like 130 people have solved part 1, so I'm not the only person being dumb here, at least. So that's nice. I'm trying to think if there's anything I can do to... You've used C#, JavaScript, and TypeScript, so... Okay, so you've used nothing, but you don't have like a huge breadth of languages. I think at work I've submitted code in somewhere between 10 and 20 languages. You just kind of end up touching a lot of stuff. Everything's written in its own little configuration. Also, I'll keep looking this way because that's where my other computer is. Java heap space out of memory. Okay, that sucks. Because there shouldn't be that many states. We could probably make this set of states a lot smaller. Rather than simulating and then trying to purchase everything from every point, we basically can like simulate each thing until it gets to the next point it can buy an ore robot or so or whatever, you know? Like, anytime you purchase a robot, you want to purchase it as soon as possible. So really what you want to do is you want to have 4 robots, each of which are like saving up to be able to purchase the kind of robot that it can purchase. Those are the ones you're used to. Fair enough, fair enough. Okay, so if we want to do it that way, then a simulation... What I really want is not... here, let's keep going down to simulation. Yeah, simulation... Got all these helper methods, but really what I want is... This increment method is fine, but the important methods are going to be void simulate until or robot purchase. We're going to have the same for clay robot purchase, obsidian robot purchase, and geode robot purchase. Right? Take a sip of water. Yes, sir. Absolutely. It's always a good reminder. So... Well, not can purchase or robot. And these all need to take in blueprints because our abstraction is a little weird right now, which is okay. Blueprint. Or time is less than, and where do we have 24 in here? Do we just have it in one place? Private, static, final, int, max, simulation. All right. Wonderful. Sorry about that, folks. And if we go and look, oh yeah, you guys can hear me now. We're doing great. Okay, is the mic good now? Can we hear me? Are we set? How you doing, Yoshi boy? All right, great, fantastic. There's a big lag between when I can see your chat message. Okay, so what we were just saying before we were rudely interrupted is I don't actually care about simulating every possible thing, because like for example, imagine a simulation where we like have enough to buy an ore robot but don't, but then wait one and then buy an ore robot. Like there's no world in which we do that. So instead what we need to do is we need to simulate forward we want to simulate forward until we've bought whatever robot that is. So we want void simulate until purchase of or robot or end. He's taking a blueprint. Oh great, I have a bloody nose. We're having a great time here, folks. I'll be right back. Oh, that's really cool. Because I just made it with Python, right? Apparently your React dev tools are activated while you're on Twitch, so I guess it was made with React. Fair enough. That wouldn't surprise me. React or Angular are the two big ones. So, while time is less than, and we put a thing up at the top here, which is undoubtedly gone. Private, static, final, int, simulation, end time is 24. Blah blah blah. All time is less than simulation end time, and not can purchase or robot blueprint increment. This page is using the production build of React. Nice. That's cool. I've never been particularly good or particularly knowledgeable about web development. I do know a lot about Android development, though. I want to increment, and then when we can, then we want to purchase or robot blueprint, and then return, basically. So now we want the same thing. 1, 2, 3, 4 times. And we want a clay robot. Can purchase clay robot. Purchase a clay robot. Now this is going to be obsidian. We're just going to copy that. We're just going to delete the word or. Put an obsidian geode. Oh, it needs to be wrapped in if. If can purchase or robot blueprint. And the basic gist here is that we want to, like, we don't want to end up in some of these things require if can purchase clay robot blueprint. The gist here is that, like, you might end up in a circumstance where you've run out of time, and so you don't want to, like, try and purchase a robot when you can't or whatever. Although even then it's not really going to matter. The number of robots you have if you run out of time isn't a big deal. So actually, these are unnecessary because we don't have checks that are going to fail if that doesn't work. Let's go back and hit the button so that the sound comes on. Fantastic. Okay, steal a robot. So now we want this is all the recursive solution. So actually what we want is this solution. And we're going to move this up just so that it's the one that we'll actually call. Now where is it? Here. We don't need to think about caching. Max geodes from blueprint. Q, new simulation. While not, Q is empty. We don't care about this right now. Current state greater than or equals 24. Great, that's all fine. I guess I also just want, like, simulate until end. Void simulate until end. Blueprint. I guess this isn't strictly necessarily, but we're going to add it anyways because I want to be sure that I'm right. Animation end time. Increment. Great, and then it just returns. Great. So now that's all recursive stuff that we don't have to deal with. In fact, let's take all this and comment it out. We might come back to it. It might still be useful, but we're not going to bother committing and dealing with all the rebasing and whatever. 0, great. So we basically want the queue in fact, try writing out the clock. Simulate until end blueprint. And get rid of this outer. Go, next geodes greater than current state, do nothing dot geodes. Great. Don't need to add that to the queue because just incrementing doesn't do anything. So now we want simulation until and we do want we'll do it after this if current state dot time greater than or equal to simulation end time. Continue. We will have already covered that up above. Next, or robot equals current state dot copy. Oh, got another follow. Gotta go figure out who that's from. It's from Intervision. Thanks, Intervision. I have a nosebleed right now and I'm trying to self-admin code. Dot simulate until first of or robot or end blueprint. No, that's not gonna do what we want. Cut get next or robot dot simulate until purchase of robot. Then we just want q dot add get next or robot. We just want to do that same thing for each of the kinds of robots. So want here, want this here. Get next clay robot. So this is going to go here. Get next clay robot. Get next obsidian robot. And it's a good thing that these names are all really long. Oh, and this needs to be clay. Dog, what are we doing here? And this is going to be get next geode robot. Copy that. Man, it's a good thing this music runs out so fast. Otherwise, you might actually get to, you know, enjoy yourself for a minute. Okay, there we go. We don't have to carry about any of this. This is all gonna be fine. We don't actually have to deal with multiple purchases anymore. Cool. So this should be fine now. So this can go here, and now we should try running. This should go much faster because we're not simulating a bunch of stuff. Rust does seem like a good programming language. I believe it. What? How is the queue size so huge? The queue size is like worse. So let's go down. Oh, did we not like simulation? An increment does increment the time, do all the stuff, and then it purchases a geode robot, which is great. So let's, okay, we've got to debug. It's the only solution here. So let's go back to here and see if I can figure out, obviously, why things are bad. Okay. So now we've got a new simulation at time 0 with one ore robot. Got the current state. That's fine. Print out all this stuff. I don't care. So current state, do nothing. Is a thing. Got a bunch of ore. That's great. It has 24 ore, which is right. And it has no geodes. So that's fine. Current state is not that. Now, what is get next ore robots? Yeah, and the queues of size 0. It's at time 4, and now it is another ore robot. Is that right? What's the current blueprint? Ore robot ore cost is 4. Is that right? Yes. So that's right. In the when you, oh geez, sorry. So when you, this is not quite right. Simulate until purchase of ore robot. It's gonna purchase the ore robot, and then we have to increment one more time. Because you can't, when you purchase the thing, like, you have to, during the time when it's being made, you never end up with 0 of a resource. Let's show that. So if we go back to today, go to here, there's 1 resource, you have 2 ore, you spend 2 ore, but at by the time you have a new clay collecting robot, you now have 1 ore again. So like during the time by the time you have clay collecting robot, you don't have 0 ore anymore. So you have to increment and then do the thing, which is fine. Okay, this is all fine. So simulate until whatever. Current time greater than or equal to whatever. Okay. Well, let's rerun and let's try and see if we can figure out why the queue is so huge again. Yeah, the queue size is enormous. Yeah, so we're heap spacing again, which makes sense if we go back and look here, look at the performance. Yeah, just a huge balloon. It does run a lot faster, which is nice. So yeah, let's see. So let's debug. We're gonna add another breakpoint here. No. Play here. I know a little bit of this debug information is behind. I'm sorry. That's just how it has to be. Don't care about any of that. Okay. Simulate until ends. Don't care about that. Let's go back to the music real quick. Start from the top so that it's louder, faster. We're good. Get next or robot. Current state.copy. So get next or robot. Now it's going to simulate until there. So time is 5. You have 2 or robots. That seems right. Get next play robot. Does it time 3? Cool. So now we have 4 things in here. Whoa. Well, that's probably wise we keep adding all of these things. Okay, that probably didn't help. That we were just inserting the same thing over and over again. And now if we take a look, our heap size is still really big. Are we counting down? No, our queue size is still enormous. Something weird is still going on. Okay, next shield robot, next obsidian robot, next clay robot, next ore robot. Let's add a little if else. Because it looks like we're getting pretty, yeah, current state's time. It's getting pretty high. Okay, so let's see. If get next or robot dot time greater than or equal to simulation end time, then we want to do the whole this, else, that. We'll see if wrapping that in a couple of places helps. If, let's just do this, and then we can update it. And now I want this same thing. Instead of this, it's going to be this, and then one more time. This doesn't seem like it should be the thing that fixes it, but far be it from me to stand in the way of progress. Nope, we're still ballooning in size. Our queue's getting smaller. And our queue's getting bigger again. Yeah, Java heap space. Rough. Let me think. So this array deck, let's look at the things and see, is there anything I can do to, first of all, this array deck we can make just huge. That'll at least help it run a little faster. Yeah, there we go. And let's add another thing here. Current max geodes plus max geodes. We're actually going to move this one higher, and we're going to run again, and we're going to see whether or not we're touching useful cases or not. Max geode count 79? That can't be right. So something weird is happening again, because again, the max geode count here should be 9. And the second one should be 12. Again, for the level data. Oh, what did we just do? What's going on? Oh, we did that. Okay, pull this back onto here. Thank you. Yeah, something's going wonky here. Let's look. Simulate until end. I'm just gonna keep incrementing. Now let's see. Increment says time plus or plus equals O robots, clay plus equals clay robots, obsidian plus equals obsidian robots, geode plus equals geodes robots. Yeah, and so we just simulation end time. We did have set to 24, which is great. Or robot, and then we person or robot, clay robot, purchase clay robot, obsidian robot, purchase obsidian robot, purchase geode robot, purchase geode robot. And again, the music stops. Annoying. Or clay, obsidian, geode. Okay, and let's check these. Or greater than or equal to, or robot cost. Return, or greater than clay robot or cost, obsidian robot or cost, and clay is greater than or equal to obsidian robot, clay cost, geode robot, obsidian cost. Yes. Oh. Obsidian. There we go. That should at least help a little bit. Our max geodes is still too high. Some quality level 38. What's it supposed to be? 33. So we're just a little high. Or how about 5? Cool. Okay, let's go back to debugging. We're just gonna step through. Queue is empty. Got a thing, don't care about this. Current state. Okay, simulate until end. There's no geodes, so we're good. We're also not at the end. Got next or robot. Current state.copy. Simulate until purchase of or robot. next ore robot time is 5. Is that right? Yeah, that would be the case. If it were going to do that. So that's not the one that we can check though. So let's just go over here. It's going to add it to the queue. Okay. Simulate until clay robot. Clay robot time is 3. If we get next clay robot, there's 1 ore. There's 1 ore robot. It has 1 clay robot, and the time is 3. 1 ore robot, 1 clay robot, and 1 ore. That seems right. Oh gosh, people are talking here. Rust does seem like a good programming language. The cargo doc command is pretty neat. I have no clue what cargo doc does. Sorry, I'm just trying to solve a problem, so I'm intermittent here. Hopefully you'll forgive me. Normally I try and be a little bit more active with chat, but I'm not even at home where I can see that the chat is happening. Normally I have like a setup that makes this much easier, but I've got to look way over there in order to figure out what's going on. Then I've just got a bloody nose, and it's late at night, and I'm feeling dumb right now. There's just some easy bug in here, I'm sure of it. Oh. We need to make sure that it's equal. There we go. Otherwise we're checking something that's like happens too late, which is not what we want. Because if you would purchase a robot and the time goes later, then it doesn't matter. And we were walking on thin ice with a lot of this stuff. Great. So now if we run, do we get a better answer? It still is way more RAM than I would expect. Why is this so much RAM? Sub-quality level 32? And what's it supposed to be? 33. Okay, well, that's... I see. So, I was just thinking about how can I debug this? whenever increment gets called, which gets called, is the only thing that moves stuff forward. Before we do any of that, I want we want history.add get cache name. I'm going to change get cache name. Time. We're going to move the robots down to the bottom. Obsidian robots. Clay robots. Nope, that's... Ugh, the formatting's getting all weird. Okay, we've got or.clay.obsidian.geodes // and then the number of robots. And I also, in addition to max geodes, I want string best history. Best history equals current state dot history. Best history equals get next or robot dot history. Best history equals get next clay robot dot history. Best history dot equals get next city robot dot history. I'm gonna have to sneeze. Okay, my bloody nose appears to have abated, so we're gonna wait for a little bit on that. History dot equals get next geode robot dot history. Blah blah blah. System dot system dot out dot println history of best simulation for string line in best history system.out.println line. Equals collections dot empty list. Great, fantastic. Oh, it's because I forgot to copy new simulation dot history equals new array list history, and that should copy the history. So here, and just wait until we see big printing that looks different. Some quality level. Okay, so now we can compare this. So we have, nope, we need this lower. Okay, so let's move this up and let's compare it. So, blueprint 1 example, but the best answer is 9. We got the best answer 8, so that's bad. So you have 1 ore and 1 ore robot, you have 2 ore and 1 ore robot. You spend 2 on a clay robot, so end of 1 at the end of 3. We have like an off by 1 or something. Yeah, and so it says that we get our first, we have 1 open geode, we You have 2 open geodes. A minute 20. That seems right. Minute 21, you have 3 open geodes. Minute 22, you have 5 open geodes. Okay, so we have an off by 1 in the way that we do purchase or simulate until purchase. Oh, nope. Undo whatever I just did. So come here, simulate until end, that's fine. Okay, do we want to make it so that... Because yeah, what's going on here? If we go back to the run, at the end of minute 3, we should have 1 and 1.1. 4, we still do have 2 on 1, so that's fine. Things start getting weird there. Okay. So let's see. Purchase ore robot, remove some ore, and add some ore robots. I'm trying to think if there's any... What's the best way to describe purchasing an ore robot? Okay, we're gonna make purchasing a robot work slightly differently. It's like really when we're collecting our history. So like the trouble is that we're incrementing and then we're purchasing the robot. Okay. So in increment, I have like a thing that updates the history. And instead I want void increment without history. It's going to do all this stuff. And then I want void update history, which is going to do this. So now, now when I come to these purchases, I want increment without history. This is going to help me. This is going to help my like printout at least read better. Update history, which we also want to copy in those 4 places. Great. So now if I rerun it, then we stop whenever we see the slashes, which is now. Answer's still 8, but our thing should look more like theirs. 1 ore, 2 ore, 1 ore, 1 ore collecting robot, and 1 clay collecting robot. That's right. 2, 1, 1, 1. I have 1 ore. I have 2 clay. I have 2 clay collecting robots. I still have 1 ore robot. I have 1 ore. So I have 2 ore. And I have 4 clay. Same number of robots. I create another clay collecting robot. So I now have 1 ore, 6 clay, and 3 clay collecting robots. 2 ore and 9 clay. 3 ore and 12 clay. 4 ore and 15 clay. I spend 3 ore and 14 clay. So I have 2 ore, 4 clay. And I now have an obsidian robot. That's at the end of minute 11. I need 12. I have 1 ore, 7 clay, 1 obsidian, and I now have 4 clay collecting robots. I have 2 ore, 11 clay, 2 obsidian. I have 3 ore, 3 clay, 3 obsidian. That is all correct. Spend another, so I have 1 ore, 5 clay, 4 obsidian, and I now have a second obsidian collecting robot. This is all like spot on here. 2 ore, 9 clay, 6 obsidian, 3 ore, 13 clay, 8 obsidian. Yeah, it's something happening right here. Oh. So things are good. 296 is correct. 313.8 is correct. 217.3 is correct. I should have 321.5.1. So what happened there? Bought another ore collecting or another clay collecting robot. So why is this best? Like, yeah, obviously if you delay yourself by 1, like that shouldn't work. But why is this the one that's coming back the best? Cool. So let's put a breakpoint inside of simulate until purchase of geode robot roblox. Yeah, we don't have to actually, no, that's not going to help us because unfortunately we don't have a conditional here. So we've got the right answer, except it doesn't, we're just like missing one branch. So what's going on there? Yeah, because again, 1421 is correct. But we should get to 1422. Instead, we're waiting to get to like 1522 or whatever, which is dumb. For 21, we should just buy another geode robot. There's something subtly wrong. This is incredibly frustrating. Let's see if the answer for the other one comes out decently. Or a sensible way. Still slow AF. Feels like something's wrong. Yeah, how is the queue size so big? Here, let's answer that question, actually. How is the queue size so big? So when we get into here, let's look at the, let's stop, let's debug, and let's look at what's in the queue. So we start at the beginning. In the current queue, there's nothing, because there's only the current simulation, which is exactly what we want. When I get to here, let's look at the queue. Can you really buy 7 clay robots in that period of time? Let's look at the history. So fine. And let me see. The factory, does the factory, let's go back. Construct any type of robot. I see. Okay, well that's good news. So we don't have to account for multiple robots in a single turn. So we had 4. We had 5, which is 32. And then subtract 14 to get one of these. That's kind of wild. So our current... Actually, let's go down and futz with the variables for a second. That's blueprint. Yeah, I want to mess with the order of these so that it reads more legibly. So we want this here, this here. Then I want to move these around. Nodes. Oh, that's geode robots. What's going on? Okay, do we have all the robots? Geodes equals 0. Is that why things are getting weird? No. Okay, let's stop and rerun. See if we get anything weird. Play again. How many things are here? How many robots got purchased in this thing? 1, 9. So what's 4 to the 9th? 262,000? That's... Except how many robots are purchased here? Like, is that the real... 10, 13, so... What are the 13? Not exactly. Now we're at 67 million. Probably had a little pruning. Oh, 1 second. I need to start charging my phone. Which is at 30%. Like, we're getting the right answer. I shudder to think what part 2 is going to be. Just disgusting. Let's go even look at the stats. Yeah. Okay, so 1,000 people haven't even done today yet. That's nice. Here, so let's add a little bit of pruning. Our time is less than less max geodes, right? Because you have to be able to produce. Is there enough time to be able? Nope, that's not quite right. Damn. We need like the sum function. Okay. So we're gonna do something. We're gonna do something extreme right here. If current state dot. So it was at the point where it should have bought a second geocracking robot that it didn't. Gonna try and find that state exactly. It's gonna seem kind of nuts, but trust me on this. I just want to debug right there. Current state, time is 19. I'm at 1421. Let's look at the current state's history. Let's see. 1 1 1 1 1 1 1 2 1 2 1 3 1 3 minute 8. It's 1 3 minus 1 3. Okay, well, whatever. So we're at minute 18. Yeah, we just made our first geocaching robot. Great. Oh, what is minute 19? Okay. So this is going to give us 7. Right? Oh, that's probably a problem. There we go. So let's stop. Let's rerun it now. See if that fixes our issue. Again, just another tiny bug. Nope, still 8. Stop and rerun. I'm actually only overwriting herself. I'm still off by 1 and I don't know why. Let's look at these state updates, make sure that it all plays nice. Okay, great. What's going on? Just how are we off by 1? Okay, let's try debugging again. See what we see. Okay. So our minute here, at the end of 1 minute, we have one of each, 1 2, 1 2, 1 3, 1 3, 1 4, 1 4, 1 4, 1 4 1, 1 4 1, 1 4 1, 1 4 2, 4 2, 1 4 2 1. Okay, so let's jump down. Actually, let's just play to the next one. Just know it. 22. History size 18. So 18, 2, 17, 3, 0. This should be the one. So we go down now. So if we remove the history for a second and we look at current state do nothing, geodes, it's going to get to 6. That makes sense. That is better. Our time is not that. Get next door robot, don't care. Next lay robot, don't care. Okay, next obsidian robot, don't care. Get next geode robot. Where is get next geode robot? Time is 22. Is that when the geode robot gets opened? We look at it. No. What's wrong? Okay, let's stop and redo this debugging. In the current state, time 19, 22, 18, here we go. Get back down to where we're purchasing the next geode robot. Here, step in please. Step in please. This.ore, this.obsidian. I have 7. I currently have 3. I step up. And now I increment. So now time is 19. And if I look at this, 19, I now have 5 obsidian. So if I go again, now I have 7 obsidian. So this should be true. And if we step in, true. Oh, there just needs to be an equals greater than or equal to. I just missed an equal sign. Wow. Okay, so stop, run. Wow. I usually don't make small mistakes like that, but this problem felt specially designed to cause small issues. Are we gonna run out of RAM again? Why did it get real slow all of a sudden? Two sides is 12.4 million. We'll try 12.5 million next. Damn. Talk about frustrating. What's going on, CPU? We're still cracking away at it. So that looks perfect. But for the second one, for some reason it's hanging. Let's stop. And let's make this update way slower. Okay, run again, please. Every million iterations, you can tell me what's up. $3 million, 4.8 million, 6.3 million, 7.2 million, 8.9 million. $11.6 million. Now it's going to slow down again. For reasons I'm not entirely sure of. Yeah, why do you get here and slow down? So we said, what, 4 to 3? 67 million? Attach debugger? Does that work? Nope, the whole thing is frozen. We can get rid of this at least. That's nice. Is it still running? Now if I attach debugger in the middle of it, is it gonna run? Just click stop, see if that helps. Yes, it does. Is it trying to copy everything over? How big did I make this? This is 70 million. Should be fine. We haven't approached that. If we go back to the run log, it's only 12 million elements in there. We're only running a million iterations, so we can only add 4 million more. Let's go back to the help. Change memory settings. Let's give it 7 gigs. Save and restart. Because we're still not hitting the cap. So the IDE itself uses a fair bit of RAM. Is there some reason we're chugging computer? Trying to index. Okay, we're sitting at 8.3. Should be 7.6 available. Now when we click run, you should have as much as you need. Okay, let's put you on the right side here. Okay, we're doing great. Have a force garbage collection. System.gc. Maybe that's the issue, is that we're running into the garbage collector. Because if you go back and you see like this dip, like maybe we're trying to garbage collect now. Okay, while that's sitting there doing that, let's go up here. The only time to tell it to garbage collect, well, the first place we want to is for sure here. Have it sleep for a second too, so that it can do some of the garbage collection stuff. Let's stop and let's watch as it runs again and see whether or not the profiling is going to turn out okay there. So it stopped, the RAM has come back down, run again. Okay. Okay, so system.gc appears to have worked a little bit better. So we're at 2 million. We're at 3 million. We're at 4 million. We're at 5 million. We're at 6 million. We're at 7 million. We're at 8 million. Are we going to get to 9 million? Can I see 9 million? Nope. Okay. So now, I know this is not the right solution, but we're still going to call system.gc here and thread.sleep 1000 here, just to give it a little bit of time. We're going to stop, we're going to rerun, we're going to see if we can figure out the RAM issue, because it's not like failing. Throws exception. Bam, did it. You're welcome, compiler. Can we get to see little drops? Yeah, cool. And again, every time this prints out, we should see a little dip. Let's hit the same limit. Again, I wonder what it's doing. Here, we're gonna make this slightly more complicated, just because I want to understand. Or hit stop because it's never done anything. Count greater than. If you look at that, the ID is just totally broken now. 8 million. Oh hey, we finally got the Java heap out of space. Okay. Which again is a little surprising to me. Can do this and try and narrow in on where exactly it happens. Of course, this is going to make the first part take a lot longer. The second, well, I guess it's going to make the second part take a lot longer too. Because that's 1 and we're trying to get to 8, so. Oh, easy solution. Cool. Now, in theory, it'll take 8 seconds for us to get to 8 million, but it's been running slower than that regardless. I wonder if the resource monitor will tell me how hot my computer is. The time when it would be nice to be at home where I could just turn the RAM up insane. Yeah, Java's just using it all. Nice, a little better. We're at 66, 67. Okay, this isn't telling me anything new, so I'm just going to keep staring at this graph. 10.5 million, 10.6 million, 10.6 million, 10.8 million, 0.9 million, 11 million, 11.3 million, 11.5 million, 11.5 million, 11.6 million, 11.8 million, 12 million, 12.2. Looks like 8.3 million is our winner. Though again, it's surprising that it stops. Oh, nope, there's 8.4. Just slows to a crawl. Oh, I've heard this before. I hear this on like a golf YouTube channel that I watch. I've only been at this for 2 hours. Oh, well now, actually. This should make stuff a little faster. Yeah, there's some stuff here, but we don't care. All the references to history are gone. So now what happens if we run? Yeah, get rid of this. Take me to the next one. Because I only want that stuff to exist. We could wrap all that in debugs, but I'm not going to. There we go. We run way faster when we're not trying to copy a zillion strings. Isn't that nice? Max geode count is still 11, which is kind of surprising. So it should be 12. There's 12. Oh yeah, and our RAM usage is way lower. So we can probably turn debug off and try and see what answer we get. So let's look while we wait for this to run and see if it finishes. Let's try and look at our input and see if there's going to be anything awful. We're trying to see if the values are really low for any of them. No, they're all high. This is great. Okay. Cool. So let's set debug to false. And just stop and rerun. Static final boolean force GC is false. Debug is true. Zone quality, yeah, it seems right. Yeah, so now let's go down to debug. If force GC, then we want to do all this. Cool. Even this, I'm not sure how many we need. Whatever, just run it. Did we set debug to true? We did. Oh yeah, this is too many. Every 10 million, please. Stop and rerun. It's just too much printing. Wow, we're computing blueprints fast. And now we're getting some awkward ones, but that's fine. Our RAM usage is fine. Kind of surprisingly. Not that surprisingly, all the numbers in our test input are pretty high. I'm going to be amazed if this is correct, though. 208. We need another new line here. There we go. For next time. I'm not looking forward to part 2 here. 50 million? Oh no, we finally got bugabaired. Ugh, we were so close. Wonder which one got it. went up. IntelliJ if Java more heap memory. So memory heap of the IDE. Help. Have I been editing the wrong thing? Custom VM options? Oh no, it's right there. XMX 7035. Let's set it to 8192. Save. Help. Save and restart. And let's see what happens. Huh, these answers are all really old. Yeah, 2013, jeez. Alright, so go ahead and run it. But actually... I is less than blueprint list. Dot size plus plus I. Blueprint equals blueprint list dot get I. System dot out dot println starting on blueprint plus blueprint or plus I plus 1. There we go. Now let's stop and rerun. And let's take a look. Starting on blueprint 4, 5, 6, 7, 8. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. That was 29, the one that sucks. That's real annoying. It is, and of course it is, because these two values are low. Ugh. Yeah, and if we look at our RAM usage, no. Current queue size, 60 million. We're only at, what? So maybe it's just mad because I set a weird, like 70 million here. What happens if I make this like, I don't know, 140 million or something? Because the queue size was growing. So first the queue size is growing way faster than the iteration count, then it's growing slower. No, it's going faster, it's going faster, it's going faster, it's going slower. So yeah, let's try it just with a bigger thing. But again, we know why that's bad. Of course that's bad. Seven, 8, 9. Let's go ahead and do this. It's going to save us some time. There we go, much faster. 6, 7. Up, and then we done goofed. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Yep, same stuff. Same stuff. Gonna crash right here? Nope, now we're still good. A little slow, but we're still good. Oh, what's the code for? Great question. I mean, my chess rating is depends on where you check. USCF, it's like 1160. On chess.com, it's like 1300. On Lichess, it's like 1750. Crap. Still hit the out of memory error. Okay. So let's go back to this, and I can explain what the code is for. Let me figure out how long ago you asked that. Okay, I have no way to figure out how long ago you asked that. Let me see. When did this happen? Anyways, the code is for Advent of Code. I think. Oh crap. Gotta pull it up on my cell phone. There we go. I'm live. Go to my stream manager. Let's see if this is live or not. Yeah, there we go. That explains where the the competition that I'm doing. Yeah, so we do this. Instead of every 10 million, I want to know every million now, because I want to see how bad stuff is getting. This is 140 million. Which again, we aren't like hitting the copy. We're just trying to get to 29. I think we're on like 25 or something. 27, 29. So this one should get up to like 50 or 60. Yeah, we're chugging along. Things are getting a little slower. Yeah, we're starting to hitch. 62, 63. Current memory usage is only 13 though. This is bizarre. Okay, so let's see why it's not using all the RAM. Default values 20,000. What? No. Eclipse ID, that's for Eclipse. Don't care about that. Use memory heap. Cool, so if we go to help. So now if we go back to that, is it still there? It is, except we typed it wrong. XMS. Okay, and the other thing I want to do is I want to make it so this is faster. And then I want to set this to be true. I want to save all of this stuff, and then I want to help. Cool. It's still set? Yes, it is still set. Now we wait for it to like warm up and play nice. Should ought to. Using 9 gigs of RAM. Oh, that's kind of annoying. That means I only have 7 gigs left. Okay, let's see what's using all our RAM. Chrome, mostly. Okay, well, there's 2 things open. Let's close the other one. See if that helps. It does some. What happens if we pause this? Does that help? That was our CPU, not really our GPU. Let's close a few of these. We're getting there. Actually, don't even need the text input because we have it. That is, it is a surprisingly big difference. The last thing we'll do is we'll close our stream manager because we have our phone for that. Okay, so now if we look at our performance, total RAM is at 7.9, so we should have 8 gigs of RAM left. Is there anything else open on this computer? Not really that we can close. Okay, gonna have to hope that's good enough. Okay, so we're running, things are going great. Let's see if we go to performance. Still fine. Is there 5? Is this the one that's bad? Can't tell. No, it's not. This is 22 now. $24 now. 26, 27, 28, 29. Here's the problematic one. We're still like asymptoting in a way that makes me uncomfortable. 67, 68, 69, 70, 72, 73, 74, 76, 76.3. Go down, go down. Come on. Do another one and go down. 76.2. Java heap space, damn. Okay. I'm gonna add something here just because I'm curious. System.out.println current state representation plus current state dot get cache name. That should do it. Please run again. And actually, we can just delete every line that's not line 29, because that's the only one that matters. Come back to them. There we go. Run, please. Oh, I was looking at these and I was like, geez, but these are actually not unreasonable. There's an interesting caching data structure that would be useful here. In particular, what I'd like is I'd like to give it the right part of our current cache name, which is the number of like robots that we have there. And then I'd like to give it the left side, which is the amount of like different ores that we have. But I'd like for it to search for the current robots, but any like lower number of ores for the same number of time as well. Or any higher number of ores for the same amount of time as well. Alright, so we're going to do the same thing, but now that we've got a better implementation, now I'm going to do the same implementation, but recursively. Is that going to help us at all? That just puts the queue on the heap, or on the stack. What do you think about it? What else is using up all this RAM? Oh, this is hard. Okay, well, let's turn the music back on while we think about it. Let me look at the stats, see if a bunch of people have solved this. Only like 1,700 people. Um, this gonna help? I'm trying to get something where we like truncate. Which the maximum geodes you could get is... oh, that's not quite true. Yeah, that's better. Okay, let's see if that helps us at all. I'm just trying to come up with something that gets us to terminate sooner. Really? Is that true? Okay, let's look and see whether or not this screws up. If that's all it took, I'm going to be like insane. Trying to see if the thing comes out right. Comes out right, okay. Apparently all it took was pruning the end. That's wild. $21, $23, $24, $25, $26, $9, $30, $272. Let's see if that does it. My answer's too low. Okay, I gotta look because it got weird. Yeah, I really want to be able to see this. Let's debug and see what's going on. Don't care about this. XGO is 2, blueprint ID is 1, so the sum quality level should be 2 now. Sum quality level is 2. Next geodes is 2, sum quality level should be 6. Fantastic. Next geodes is 0. Geodes is 0. Next geodes is 1. I is 4, so we should be adding 5. This should be 11. Yes. Why are we running so slow now? What's going on? Okay. Next geodes is 3, blueprint idea 6, we're adding 18, should be 29. Fantastic. And again, it's super slow and I don't know why. Okay, so now in the debugger, 7 to 14, 43. I don't know, just run the whole thing. Stop and rerun. Except this part I need to be 10 million or something. Yeah, stop and rerun, please. It's taking too long. Look at our RAM usage. Why is RAM usage so high? Oh, it's just allocated the whole thing. Fine. How did we get from 240 to 266? That doesn't line up. That's probably why. Parts 1 dot length minus 1. There's some quality level should obviously be bigger. There we go. Now we're getting bigger at the rate that we would expect. Okay. It's been a good 3 hours. 1650. Did we add by an amount that we expected? Yes, we added by 2. Cool. Let's see if we get the right answer now. We did it. Okay. Are you choosing the best blueprint? The elephants found some food of their own, so you're not as much of a hurry. You figure you'll probably have 32 minutes before the wind changing direction again. You'll need to get out of range of the erupting volcano. Fortunately, one of the elephants ate most of your blueprint list. Now only the first 8 blueprints of your list are intact. 32 minutes, the largest number of geodes in blueprint 156. Way to achieve that is blah blah blah. No longer have enough blueprints to worry about the quality levels. Instead, for each of the first 8 blueprints, there's a large number of geodes you could open, then multiply these 3 values together. Don't worry about the quality levels. Instead, just determine the largest number of geodes you could open using each of the first 3 blueprints. What do you get if you multiply these numbers together? Okay. So we can actually just run. Okay, here's what we're gonna do. Just put everything in here. Gonna put it all just in part 2. Then what we're gonna do is we're gonna change this to 32. We're going to delete all of these. Yes, use well. Get deleted. Thank you. For part 2, we are going to see some quality apply geodes. So 1 times equals next geodes multiplied. We go here. I'm going to call part 2. And then what we're going to do is we're going to take this thing. 4. We'll come back and fix this later. Part 1. Part Let's run it and see. I expect that we're going to have issues now. Yeah, we're almost certainly going to have issues, so we might have to... Yep, that's a lot. Let's look at the RAM. It's high. Luckily, the truncating seems to be helping us some. The queue size is manageable, if only just barely. Oh, and the queue size went down. And back up. $75 million. 69 million. Went down. 64 million. Keep going down. 58. 52. 44, 39, 37, 34, 36, 17, 10, 3. Nice. So we can get... Really? Is that all? Oh my gosh. Oh, I can't believe it. Oh my gosh. I'm gonna cry. Okay, let's put some music back on. Let's go to the leaderboard. Let's go to our personal stats. 1870, 1345. I can't believe it. Part 2 took us 4 minutes. Part 1 took us 3 hours. Our computer crashed in the middle of it. Let's go to the private leaderboards. Yeah, of course no one's done this. Jesus. I can't. Why? What about our representation was so bad? Yeah, geez. Okay, we gotta do some cleanup. But I'm not gonna do a huge amount of cleanup, actually. We're gonna do the problem statement, because doing the problem statement is relaxing, is what I tell myself. It isn't, but it's what I tell myself. Let's paste. Let's get rid of the project view. Let's go back up here. Here's all this nonsense. Not enough minerals. Form obsidian. Geode cracking robots. Obsidian collecting robots. Special purpose. Clay collecting robots. Anything you'll need. Or collecting robots. You have exactly one ore collecting robot. Robot, blah, blah, blah. New blueprints, for example. It's so hard to bother me at this point. Eligibility. Okay. 24 minutes. Blueprint 1 as an example is 9. All the way down to 24. However, blah blah blah. Let's see. So I now want quality level. Multiplying the blueprint's ID number, the large number of geodes. 9 geodes, so its quality level is 9. Second blueprint has ID 2. 12 geodes, so its quality level is 24. If you add up the quality levels of all the blueprints, you get 33. I want to look and see how fast people solved this problem. What do you get if you add up all the quality levels in your list? Your answer was 1650. Goddamn right it was. 32 minutes. Eat most of your blueprint list. Nicest elephant ever. 32 minutes. Large you can get is 56. Oh jeez. There we go. Does that even render correctly? It does not. Okay, well, then we know. We'll go back and fix that another day. We'll add a little linter for our thing. Down to minute 32. This is where it's nice to have a scroll wheel. I don't have to worry about the blueprint. Worry about quality levels. Two gold stars. Wonderful. Okay, so let me explain how we solve these problems, and then I'm going to go to bed. There, I certainly should refactor this, but I'm not going to. So we read in the blueprints here. And then what we do is for each blueprint, we figure out the max geodes from the blueprint. How do we do that? Well, we create a queue and we add a new simulation. And then for each simulation, we take its current state and we try just simulating at the current state without buying any other robots. And so we see how many geodes that is. You know, if it's greater than the max, we make that the max. Otherwise, if the current state time is like past the simulation end time, or the maximum geodes that we could get from the current state is less than the current max geodes, which means that, like, you know, we found a solution that has a lot of geodes, but the one that we're currently on, there's like only 3 minutes left, so you can only get 6 geodes if you could even buy robots every minute, which you can't in most contexts. Then we just ignore it and move on. Otherwise, we say, okay, what happens if we buy an ore robot? So we buy an ore robot and we put the simulation back in there, because once you buy the ore robot, now you're somewhere forward in time and you might want to do a variety of different things. And then the same thing for what if you buy a clay robot, or what if you buy an obsidian robot, or what if you buy a geode robot, and all of these check whether or not you like run out the maximum. And so we put all of those things into the queue, and the queue should get relatively large. There's 4 different robots you could buy. You could buy one, you know, at most every other minute or so, probably a little less frequently, but 4 to the 12 is like oh, what is it? I had this right. It's 2 to the 24. It's a lot. It's like 60 something million. So we ran into a bunch of memory issues and we had to do a little bit of pruning, but in general it's fine. For part 2, we do the same thing, and we didn't have to change anything because for some reason 24 was already running us into the wall. So at 32, like, we didn't run into any new issues because we'd already done the pruning. So that part we literally just ran it differently. But that's all I have for tonight. I'll clean up this code later. Let me add it to do at the top of the file. Alright, I think that's all I got today, folks. Let me go ahead and commit and push this on Git before I forget. And then I'm going to bed. I am tired. Holy crap. And so, add these two. Oh, come on. Commit and push. Push. Nice. Okay. Well, that'll do it, folks. Have a good night.